probably one of the most memorable and most interesting results in differentiation is that of the power rule. So the power rule applies when we're dealing with polynomials. And what happens is, if I have x to a power, where this number is a rational number, so remember rational numbers are where you have, it can be written as the number can be written as a fraction. Then if it's x to some rational power, then it's differentiable, and the function is considered differentiable, just straight out the gate, no problem. With f prime equal to, you bring down that power to the front, you have an n in the front, and then you subtract 1 from the power. So there's a couple of caveats here, but they don't happen that often. So the first one is that as long as this number is greater than or equal to 1, or if it actually ends up being 0. In the case where n is 0, x to the 0 is just 1, so it's really just a constant function, so it's derivative 0 everywhere. But in the case where n is greater than or equal to 1, then f is differentiable at 0. Otherwise it's not. And the reason being is that, let's say it was 1/2. So if it's 1/2, when I bring this down, I end up with x to the negative 1/2. So that's like 1 over x to the positive half, and you can't plug in 0 there. So you have a differentiability problem at 0 for the cases where n is less than 1. But other than that, you're generally good. Now, in the case where n is exactly 1, so this is like x to the 1, so it's really just x. So if f of x is equal to x, then if we use this formula, we bring down the power, so 1 comes down to the front, we subtract 1 from the power, so we have 1 times x to the 0. Well, x to the 0 is just 1, so it's 1. So blah, 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 blah. Long story short, the derivative of x is 1. So that's just kind of a simple case. It kind of pops the x off, if you think about it that way. So some examples here. The first one is just x cubed. So following the formula, you bring down the power to the front, and you subtract 1 from the power. So 3 comes down to the front, subtract 1, you have a 2. Easy peasy. The second one's a little more complicated. So what might help is rewriting this. Instead of writing the 5th root of x, we might want to write x to the 1/5 power. Now remember, fractional powers are the same as roots. So then, and if you remember, 1/5 minus 1 is negative 4/5. So that's what ends up happening over here. We bring down the power to the front, we subtract 1 from the power, which gives us negative 4/5. And if you remember, negative exponents, we can take the reciprocal to turn them positive. So we can rewrite this as 1 over 5, and then 1 over x to the 4/5 power, so it's all grouped together. And finally, we have this one, 1 over x squared. So what might be easier is to kind of think of it the way we thought of this one. Instead of writing it this way, we need to write it as x to the negative 2. Remember, this formula only works if it's in the format of x to a power, not 1 over x to a power. So if it's x to a power, x to the negative 2, then we bring down the power to the front, it's negative 2, and then we subtract 1, so negative 2 minus 1 is negative 3. So we take this piece, this x piece, we flip it, so we have negative 2 over x cubed. So realistically, that's really it. Some practice will help you out there, but the power rule is kind of going to be your bread and butter when dealing with derivatives.